Witam po przerwie.
Welcome again after the break. The last part of the plenary session, we have three presentations, and the first speaker will be Krzysztof Latkowski, SRE-BIM, as a BIM and GIS as innovation of digital engineering. The floor is yours. Welcome, ladies and gentlemen. My name is Krzysztof Borkowski, and SRE in Poland I have been for 20 years, and now I'm responsible for ASR, and I will be discussing this with you. And let me start by saying a couple of words about our company. I am not sure if it is very well known. The company is the exclusive distributor of SRE from the US. And from the very beginning, we have been dealing with the spatial information systems and GIS. And this is the fifth largest privately owned software company in the world. And in the GIS, we have about 50% of the market share in that. In Poland, we have been for almost 25 years. And we are not only SRE distributor, but we also distribute Harris software. And we are also part of the Smart International ODC. I am not sure if you know, but the shape format, so these are the formats which are widely used for information sharing, and these formats have been developed by our company many years ago. They were made available as an open source format. And a lot of effort is now being implemented for implementations and 3D data. And our software has also been used for creating of Oscar films. And we also purchased SiteScan, which also deals with imaging drones. And they create 3D models from their imaging data. And the market situation. So future customers, if they are related with some spatial aspects like resources, data, if they work with us as they need tools to keep control of their processes. So here are the main organizations working with us. And of course, we cooperate with the transport industry. And I believe 98% of large companies, infrastructure companies, are using solely or significant ranges of our software. And these big customers, and we are present among many companies. And there are a lot of GIS experts preparing spatial data and information as a sub-element of their processes using our tools. Let me also tell you what is the origin of the fact that these companies have been using our software so extensively, and what kind of changes have we experienced. Majority of our organizations, and also many of your organizations, are some kind of silo where processes or departments or tasks are carried out as an element of some areas, and information exchange is small, and we have usually quite a lot of gates. And at some point in time, you start considering which gate is the best and where to find the best information. And many organizations have observed that the approach can be different. So the question is, what would be if we were able to break all those recommendations for the projects which generate a negative value? They generate a lot of problems, and they generate extra costs on downstream. So if we break the barriers, and if we optimize the processes, concentrating on the true designing problems. And this will allow us to create operational cooperation and information exchange among all stakeholders, including the customers. So if all the tasks are concentrated on something which is available in the space, the change of the silo operation model to geocentric model and concentrating on the elements definitely puts more order into processes, and information available in the organization is well structured. So in the designing industry, if the spatial information is collected on the first stage, if we create some kind of database, full database originally, so this will reveal some threats, a number of threats or situations, which, if discovered on later stages, would require some design changes, and this would significantly increase the cost of projects. So what is our perspective from the GIS and BIM perspective? Generally, we believe that GIS and BIM are strongly interrelated, and of course these processes can exist independently, but they will never be full if so, and there's some risks will appear due to the fact that some information is missing in terms of spatial information, but we are also going to be missing information in a more broad spatial situation, like the more distant objects, facilities. So changing of the project life cycle will allow us to understand the full data flow between the designing, construction, and maintenance and operation of infrastructure. And so we use some phrases to put more order into these processes and the tasks which are used in the spatial environment. I wouldn't limit ourselves just to the construction or engineering industry, so we use the writing system and view system and analyze system. And throughout the life cycle of a project, this facilitates processes of experts and solve problems related with projects. So these are some examples. As an example of the first process, these are like permit and planning. So our system gathers and makes available BIM, CAD, MAC, PDF, Excel, some surveys, and all type of data which is necessary, which is needed, and helps to design. And before the analysis, a lot of sources of information need to be gathered. So our tools, like for feasibility studies, will allow you to better understand the data, and this will allow you to carry out different analysis. And finally, with tools like StoryMass or in-field work or browser work, so the involvement, this will allow transfer of feedback in real time, collecting of feedback. This can also be used in social consultations, public consultations. So that's very important to separate all these areas where this process can be functional. And looking at the basis, these three milestones, the system of record and the system of engagement, so this is a fundamental elements of the system, puts all these elements together. And in IT engineering, usually these are separate systems, but our assumption in our software, it is a single system which generates a lot of synergy to achieve development of organization. So we can use different types of data. So the software can organize and visualize all types of data, vector or cluster, or literal sketches, calculation sheets. And we put all this data into one single system. So independently of the fact of what kind of data you have in our environment, this data can be used to work, and this is not very common. And our system is open and integrational, so we support different formats and standards, and we have an integration with other softwares used in business, like Microsoft's SAP, Adobe, API. But we also integrate significantly with Autodesk. And for almost 3 years, we have had good cooperation. And now we create Regis models on websites. And we can use CDIT 3D to use spatial data. And also it generates trust of the users, and all the data you will have all the accuracy collection methods. All this information is available to be used and consumed directly in Autodesk software. And the solution in the market. So I have 2 presentations on how the software operates in the UK, where Skanska, Strabag, and Constein carry out High-Stein 2 project. That's a high-speed train project in the UK. So I have 2 slides on what is their perception of the application of this approach. So first of all, it was clearly defined what spatial or CAD software needs to be used, and GIS is responsible for all information for collecting of where, and BIM is responsible for all the information on what needs to be included in individual areas. And together, this is called a GeoBIM. So this is a combination of spatial information, which is supported by the structure information on the structures and how things are constructed. And how was it summarized? So the centralized GIS platform and integrated with GIS totally changes their work. And they can take smarter decisions, and it facilitates or speeds up schedules and decrease costs. And what is the most important from the sustainable development standpoint, it helps to build infrastructure which is can last for longer, also in terms of smart solutions. Thank you very much for your attention. If you wish to be a part of the innovation world, and if you wish to use spatial information more broadly, not only as a map or not LED, but if you want to have this full information, and if you want to really use all this information, so please contact me. Thank you very much.
Thank you very much, Krzysztof. BIM and GIS, digital innovations in engineering and implementation. This was this presentation. And now let me invite Krzysztof Wojsław from BIM Corner, how parametrical modeling is used for bridge structure design in Norway. Welcome. Good morning, ladies and gentlemen. I hope you can hear me well. The title of my presentation is How Parametrical Modeling is Used for Designing Bridge Structure in Norway. However, events from recent weeks made me change this title. It means how parametrical modeling leads to winning the prize for the best BIM project. The project I had the pleasure working on for the last 2 years won Tekla Global BIM Awards, a prestigious award, and not only one, 3 awards for the best BIM project in Norway, for the best infrastructural project worldwide, and the prize for the whole lot for the best BIM project worldwide from among 130 projects filed from 30 countries. And we are talking of this beautiful structure. Ranselva Bridge. It's a bridge 634 meters long, and the span, the longest span is 230 meters. Ranselva Bridge is 100 kilometers from Oslo, and it will be built without drawings. Of course, for designing, sketches and drawings were made, but at site only the model was used, and literally a few detailed drawings of elements like a detail of drainage pit or a detail of membrane, which is very hard to be modeled, so it is much easier to be presented in the form of a drawing. Contractor out of the model generate all material lists and tension cables and trenches, all that comes from the model. In this case, it was a design and build contract, which is not an everyday practice in Norway, and the main contractor is PNC. In Poland, you may know this company by name POR better, and designers, it's Sweco from Norway and Armandorito from Portugal. Please look at how detailed the model is, modeled so as to avoid collisions to facilitate work and control of collisions at site. The project is completed, and in spring 2022, the bridge is to be handed over for use. A few words about me. I'm Krzysztof Wojsław. I come from a small but beautiful town of Olecko, Warmińsko-Mazurskie region. For 7 years, I have been living and working in Norway. I got the engineering diploma at Gdańsk University of Technology, specializing in bridges and tunnels. My master's thesis was written in Trondheim, in Norway, together with Norwegian General Directorate. This year, I gained virtual design construction certificate at Stanford University in the US. For over 4 years, I've been in Sweco in Oslo as a bridge designer, and I mainly coordinate international projects and implement new methods of designing, such as parametrical modeling or VDC method. That means a method of running multi-sectoral projects. Apart from my work, I'm also interested in construction, and together with 5 colleagues, engineers from Oslo, we set up a blog. In a simple and transparent way, just engineering way, we try to explain what BIM is, and we present practical applications of BIM. We present our Norwegian experience on projects, and we draw benefits alone, and we present them for our readers. We also have a channel on the YouTube where I have my section about parametrical modeling, where I also explain practical application of parametric modeling. Okay, so let's move on to the agenda. We have very little time available today. So let us start from point 1, definition, because maybe not everybody know what parametric modeling is. And I will avoid presenting boring definitions from Wikipedia. If you are willing to, just Google them yourself. I will, rather than that, present a quotation from a Spanish architect. All what you can present in the form of geometry, you can also describe mathematically, but not necessarily the other way around. In my opinion, this quotation describes the whole idea of parametric modeling better than any other definition. Putting it differently, every geometry which is present worldwide can be described mathematically. Points, spheres, lines. But the other way around, we would not be able to do it same mathematically. When I say this, I mean thanks to creating scripts and algorithms. Let me present here just to visualize it. Let me show you how an ordinary line is created. So on the left-hand side, we have a software for writing scripts, which will create 2 points placed in space. These points have been connected with a line, and so we created a parametrical model of our line. The points need information regarding their position. That means their XYZ coordinates, and thus we can create a relationship between points and move this line. This line can be exported to a different program, calculation program, or one for creating a model as a beam or a column. This way, further relations are created. So from one line, we can create relationship between other lines, other objects, and actually we can create our whole bridge unit. Okay, that was definition. So parametric modeling is summarizing. It means creating scripts, algorithms which describe our geometry. Okay, and now why should we be using parametric modeling? What are the benefits of it? One of the best benefits is the ease to adapt to changes. And here we can see a few standard changes for a designer, like adjusting reinforcement or suggestions of a designer which can really destroy our project. After 7 years working as a designer, I found one name describing them all. It is nightmare. It is nightmare which can really destroy all our efforts put into the project. So what should we do? I always advise here to listen to this gentleman. We should get ready, because changes will come anyway. But don't wait for the changes without any action from you. If there is some risk that the way will change, let's put in a lot of parameters into geometry of the road so that each and every change can easily be adjusted, adapted. So we are looking for risky parameters which can be modified, and thus we create our parametric model, because it is not a masterpiece to create the whole model of a bridge where each and every element will be moving. We have to estimate what is actually the greatest risk and build our script following to it, our script and relations. Next strong aspect of parametric modeling is the fact of merging it by the idea with other programs. And in this case, I actually work on two programs, Rhino and Grasshopper, which let me create scripts. But they can also be other programs like Revit, Dynamo. It can be FEM. It can also be generative components. It doesn't matter here. The whole idea is in the fact that our parametric model can be sent to calculation programs like Robot, Sophistic, or ArmBridge, but also to programs creating geometry like Tekla, ArchiCAD, Revit, or NovaPoint. Now I would like to introduce to you our Sweco dream team. To this incredible and complex project, we had to hire the best people in the sector. Fortunately, Sweco is a large international company which allowed us to pick the right people from 4 different countries. And here I wanted to praise people from Katowice division, Darek and Marek. I had a pleasure working with them. They were responsible for most complex elements of the bridge, and they managed to cope with it excellently. The benefit of projects based only on a model is the fact that in every country, a 3D model will look really similarly. My experience shows cooperation on international projects that standards, according to drawings, look different in every country. It is different in Germany, in Poland, in Norway, or in Finland. Here, creating a 3D model, it will be a really very much a standard one, and everybody working on the bridge does not have to know the standards to such an extent in creating drawings or models as it had been with drawings or cross-sections. Okay, so what we have discussed definition, what parametrical modeling is. So writing our scripts, describing geometry, we have specified benefits, why it is worthwhile, adaptation to changes because we can be working with a variety of programs, and there is easier cooperation between or among other various offices. And now let's go to the examples to show you practical application of parametric modeling. Here I took the opportunity to place this picture describing perfectly well the beginnings of this project, because nobody earlier created such a large structure based on a model only. 4 years before, Sweco was the first office in Norway, and I guess worldwide too, which created the first bridge unit approved by the directorate as one based on model only. It was 4 years ago, and it was a two-span bridge, 40 meters long. And but following the development of methodology and methods of designing, like parametric modeling, the goal, the largest bridge worldwide, built only on 3D modeling based, has become ready for implementation. It appears that the crocodile is not so scary as it's presented. It's possible. Let's move on to examples. First example I wanted to show you will be the one creating geometry of piles, of columns in the bridge. In this project, we had concrete piles and steel pipes. Let's start from the program creating geometry of steel piling. Out of parametrical program, we select foundation for which geometry of piling has to be created. On the monitor, we can see gray surface depicting the surface of the rock. Quite easily, using slides, we can define the number of piles in the given foundation and span between and among them. We can also see that the length of each pile will be adjusted to the surface of the rock. Thus, we can quite easily estimate, together with the contractor, cost of the investment project and see how the costs are changing. If we click on the given pile, we can check precise information of the length of the pile, and when we change it, it will be updated. Next example depicts the same rule, but for creation of concrete piling. And in this way, we standardized our system of work. Each and every time when we create our model, we can quite easily introduce our parameters, number of our concrete piles, and span distance among them. And additionally, following concrete piles, we went further on designing our reinforcement so that it will be created following every modification. So if we change the number of our piles in this foundation, we will see that number of piles, that reinforcement will be generated anew. So we are changing the number, and automatically the reinforcement is generated with the use of some options. We can also modify length of the rebar, or anchoring or cross-section of rebars. So this was the first example. The next example will be creating a box reinforcement in the whole part of the support. Well, please believe me or not, but only one person was responsible for modeling reinforcement in the support part of the bridge, which, let me remind you, has the span of 200 meters. Only one person was modeling this reinforcement. And now let me show you how it was possible. Here we can see our support parts, elements which are mirror reflection. So on the left and right hand side, elements will be identical. The rule is that we had to find our lines and points on our bottom box. And in this case, we want to find the picture of the stirrup. Every stirrup in the box will be different because the thickness of our lower board is defined by two parables. So the height of our stirrups will be changing, but the program, the software, can find appropriate lengths by itself and connect the reinforcement into one element so that it will be easier to be ordered at site. So let's see the solution to this problem looking at a different example. Here we are looking for reinforcement, auxiliary reinforcement in the walls. And identically we find our walls, appropriate points at appropriate heights, and the software is creating the stirrups by itself, which will be in appropriate quality, in appropriate element. Every box will be different, and thus on the right-hand side we have 25 boxes, and on the left-hand side 25 as well. So thus our reinforcement is being created. Okay, so this is showing how we created the majority of reinforcement on the bridge. Now let's go to tension cables and electrical cables. Tension cables were calculated in RM Bridge, and thus using script we could export them to our model. In this case, we had assurance that what had been calculated is also present in the model, and the contractor takes information from the VG file straight regarding coordinates. So contractor does not need drawings to determine the curves of cables and placing them in a box, but themselves, using surveyors, they can establish lines of cables in the box. The example I'm going to show you is related to electrical cables, but the rule was exactly the same. In the software, we can define a distance between our cables and height also, where they run. In this case, these are electrical pipes going all through the length of the bridge and must be adapted to our parable. We can easily change the span between cables in order to adjust their position in relation to reinforcement. And so our geometry of cables had been fitted to the whole parable. This is the last example I wanted to show you. I do encourage you to watch us, to trace us at Beam Corner on our blog, where I think everybody will find something for themselves. Every division, we have Beam Coordinator. I also talk of parametric modeling and VDC method, which is becoming more and more popular worldwide. You can also subscribe our channel so as to trace our weekly inputs. Thank you for your kind attention, and I do encourage you to contact us if you have questions. Contact us via LinkedIn. I do my best to answer each question. If you happen to have questions to our blog, post at beamcorner.com. That's the address. Thank you very much, and hear you again. Thank you very much, Krzysztof. Congratulations on the award. We quite recently talked, not knowing about the results, and it appears you won all three. Fantastic. Congratulations. And I also I like your Beam Corner initiative very much. The last lecture today, presentation in plenary session, is Rafał Krzymowski from Contrusoft. Development of computer techniques and aesthetics in bridge designing, something for me. Welcome, sir. Good morning. My name is Rafał Krzymowski, and I represent Contrusoft company, where I hold the position of sales engineer for Tekla Structures for 4 years now. Today, I will be talking about aesthetics of designing from the perspective of new solutions, computer solutions. To start with, I wanted to mention only a few information items about company. Tekla Contrusoft Tekla Trimble Solution provides solutions for construction sector, among others. It originates from Finland, and now it has customers in over 150 countries worldwide. Contrusoft, our company, comes from the Netherlands. We are largest and most important partner to the company, and in Poland our offices are located in Warsaw, Krakow and Poznań, and apart from selling software, we also do localizing the software, technical support and trainings. Moving on to the subject matter, we all know, I guess, that designing bridges, well, many people participate in it, representing various sectors. These are both designers, process engineers, as well as architects play more and more important role. And the very designing process itself should be done based on engineering knowledge, technical knowledge, and the rules of art. And regarding the last aspect, or knowledge from the last field, we have it leads us to the term of aesthetics in bridge designing process. And regarding basic rules, which one should treat as guidelines in designing harmony with environment. That means units design should play together with landscape around, and then order. You should aim at keeping order in elements and taking care of cohesion of elements, and also balance between rational elements and architectural expression, as well as minimalism. So minimum of variety of forms should be a guideline. You can draw conclusions from this, taking into account all these three rules specified. Designers should aim at obtaining unique forms of structure which will give the objects a specific character, unique character. One should aim also at maintaining slimness of structure and avoiding heaviness, impression of heaviness. This leads to often to applying unconventional, irregular shapes. That means complex geometry of the unit, whereas modeling or creating such units, such objects, it's quite difficult. And it generates the whole range of challenges, problems. Among these, there is a curved axis of a bridge, variable cross-section on length, longitudinal decline, and variable decline in cross-section, and also variable support or modeling the construction lifting. Fortunately, following the development of technology and computer techniques, more and more advanced tools are available now. Here, my predecessor talked partly about 3D modeling. We have examples like rhinoceros, grasshopper, and Tekla structures. These are programs which can cooperate. What I would like to tell you about, and laser scanning. Example here may be Trimble Reworks. Rhinoceros is software for modeling. Here we can practically model any shapes regarding any geometry, whereas the benefit here is also the great number of formats supported, which allows exchange of data with numerous other types of software or solutions available in the market. Whereas Grasshopper program, it is a graphic programming language which can also be used for parametric design, and it is also an environment which works with the use of Rhinoceros 3D. Whereas this graphic software is briefly saying, based on the fact that we take the component into the sheet, and then these components are connected to the inlets of further components, and thus we obtain, for example, a complex geometry. Here, roughly a situation like this. We have input data regarding, for example, thickness of elements, the curve itself, what is the span, and then we connect it with some algorithms. Calculation follows, and as a result we obtain complex geometry, a model with complex geometry. This may also be used for generating a variety of elements or connection to other programs. Benefits of Grasshopper: we can create our own parameterized sheets for typical structure, and we can optimize designing time for typical elements. This can also be used for creating or modeling complex spatial structures. And it also allows modeling or creating similar elements simultaneously. Here, very briefly, what it looks like. Well, we have three, it's a brief animation, brief film. We have three programs: Rhino, Grasshopper applications, and in Rhino we have various cross-sections defined, defined path or line of this unit, and by connecting this, merging this data, we can transfer such design to Tekla structures. And the result here will be this kind of geometry in line with parameters specified in Grasshopper. Next film can show you, like in the first one, well, you can actually attach it to modeling linear elements, but also more to the point type elements or supporting elements, columns or barriers, elements of lighting. Like here, the whole range of various applications can be found here, whereas Tekla Structures software is engineering program used not only for design. It is used for designing structure, but as a tool for engineers. It is not only for modeling elements, but it also has the whole series of functionalities allowing you to manage documentation or control the unit. Well, here you can detect collision, or you can check whether, yes, certain elements are not in collision because the model is connected to documentation. We have drawings always up to date, and in the drawings you can automatically generate individual elements, and it also enables you tracing changes as well as quickly responding to those changes. Out of the program, we can also be obtaining a variety of reports, so we can be doing, say, pre-measurement based on the existing model, whereas the whole series of documents, macro documents, allows to faster design the structure or introducing reinforcement. Or there is a possibility to connect to production. You can send NC files to the shop floor, also Unitechnic files in case of reinforced concrete elements, or information related only to the reinforcement itself. Added value here. Some of our customers also may actually stick out in the market, providing additional value and marketing element. Tekla Structures, well, on the occasion of more complex elements of structure, it's a tool for supporting, facilitating construction of elements. We can divide structure into transport elements and coordinate it with transport possibilities or at shop floor. And we can also simulate the process of putting the structure together. Yet another possibility to use these new tools, it's laser scanning. Let me briefly say it comprises 4 stages. First, we have taking measurements with the use of special shields or balls, and then everything is connected into a cloud of points. Then vectorization follows, and 4th stage is elaboration and analysis of data. Laser scanning can be successfully used, among others, for visualization of elements, inventory of existing bridge units, objects, and also test load of the structure for tracing or carefully checking the deformations which the structure would have. Also, in designing, you can use it successfully when designing new objects with the existing ones already. So, using the cloud of points on the existing units, we can design or intertwine this element precisely. And of course, creating land maps. And example for application of all these tools is a pedestrian bridge for over Gizycki canal. It was designed in 3D BIM technology, and apart from 3D designing, laser scanning was used in order to measure the displacement on load tests. This is the second river bridge in town next to the old bridge, but the design was made by YLE Engineers company, present in Polish market for over 13 years, and the company deals with, among others, designing, consultancy, and project support. The bridge itself, or the model, which was designed using Tekla structures, won Tekla BIM Awards in 2019 in category of infrastructural projects. Whereas it was made by a team led by Piotr Żółtowski. It is located in Giżycko, whereas the challenge was to design a bridge both for handicapped people and for cyclists, but it was also an addition to existing landscape, and it had to allow small sailboats or small ships to sail under the main span. Regarding the structure itself, what it looks like, well, it was designed partly as an amphitheater, a place for local community to meet and rest. The structure here has the axis curved, and from the east the ramp goes up, then it turns and goes over the canal, and then drops gently down along an arch. As I mentioned, it had to be adapted for handicapped people, people with limited mobility, and the incline for vehicles is 6% over a canal in that town, Giżycki Canal, and in case of immediate emergency situation, an ambulance can travel on the bridge if the lifted bridge is closed. Regarding the project, its objective was also to fit into the sailors' tradition of the town. So teak wood was applied here, which also is used for building boats. Light steel structure allows to fulfill the aesthetic requirements at sensible price, and variability of cross-section changes along the span, which was aimed to make it still lighter and to increase the space under the bridge over the canal for ships to float. Thank you for your kind attention. If you have questions, please don't hesitate to contact me.
Dziękuję bardzo.
Thank you. There are some questions. Absolutely, there are some questions. And my observation is that this bridge was designed by Piotr Żółtowski. If you can hear us, if you are watching us, please join us for InfraMost. That's going to be an occasion to make a presentation to our colleagues responsible for constructing of bridges. We have many questions. The largest number of questions are addressed to Krzysztof Wojsław. I'm not sure if, yes, indeed we do have all the participants. So let's start with Krzysztof Borkowski, who was the first one to deliver the presentation. Michał Latała is asking, very interesting presentation. Congratulations. You were talking about ArcGIS with Autodesk. Is the platform basing or AutoGIS connected with the Bentley platform? This level of integration with Sigma Autodesk is not available, and the only connection we can carry out is by open standards. Unfortunately, we do not have the cooperation with them. Thank you. We don't have any other questions, and now a series of questions to Krzysztof. BIM Corner, great initiative. I have also been mentioning this, but Tomasz Reichelt is saying this again. Yes, we do our best. We do what we can. Congratulations. And looking at the presentation of Krzysztof, I consider how much a designer is an engineer and how much he or she is an object software developer. Yes, these two worlds are now interfacing, and in fact we had two groups. One was responsible for modeling. I was showing photos of my colleagues, and the average age of the team was 28 years. So this demonstrates how young people are interested in new technologies. And secondly, the designer's age was 65 years, and we have two designers. One is 61 and the other one is 82 years. So these two worlds need to connect one with each other, and it will never be the case that software will replace the thinking process, experience and knowledge of the elderly engineers is priceless, and no computer is going to replace artificial intelligence, and computers are not going to replace constructors. So these two worlds, of course, intervene and interconnect, but there is bigger and bigger demands in Scandinavia and in Poland for people who can develop software and have engineering competences. And the next question is from Mr. Pszczółka. Yes, I'm saying hello to Marcin. Are you able to estimate how many people you saved with application of this parametric modeling? That's an interesting question, and straight to the point. And so this is how we use the parametric modeling. And this project was particular. That was the biggest bridge in the world, and nobody did it before the same scale. But the technology we are using, basing of our structures only on models, has been in Norway for more than 4 years. So 4 years we have collected quite a lot of data, and so we compared tunnel portals. There are quite many tunnels, and we have 30–40% of savings. As the biggest, the largest, the most important fact in terms of saving, it is that the script can be used again, and this is where you can generate the largest savings on money and time. So if you can use the same script for more than one project, so you will have to spend less time for writing a script and using it again. Marcin Jasiński is asking, is the algorithm of modeling and of reinforcing and paling, do you use any external software, Ruba? And saying hello. Thank you. Yes, in this case, we wanted to achieve, to test what we can connect, what can be parameterized, and we manage, so we have still files, and we use robot software. We have a file, and information is transferred from robot, Grasshopper, and Tekla, and this is how we generated internal forces to calculate the pale sand. We also were able to automate the process of between the calculation software and BIM model. Michal Latawa is asking, is so advanced BIM, it was required by the buyer in Norway, or it was an initiative or a designer or a constructor that was based on build and construct, or Sweco, together with POR, the Austrian company, willing to get the Norwegian market, and that was the initiative of the constructor, as any other contractor have in their CV some projects of bridges without drawings, and the constructor to enter the Norwegian market need to follow this technology. So that was the initiative of the constructor. And with other projects today, to complete a bridge project with drawings, you need to have really good arguments for the manager, for the operator. So you have to Last year, I think no project was carried out with a standard method. Over the last 4 years, a lot of things have changed, and so it is the operator who requires standards, having the full BIM where you can read like reinforcements or geometry. Let's change now addressing of questions, as we have a couple more for Krzysztof. Rafał Krzanowski from WOA. The question is, what is the vectorization process? Is it automized? It is a difficult question. I am not an expert in laser scanning. As I know, once we had a webinar with a company doing that, and I believe it is true, that's automized, but I am not an expert. Krzysztof Borkowski from eBay. Open standards from ESS, EFC, BCF, or also Excel sheets. Yes, open format. These which you listed, but also the Excel sheets, and so we also have a tool with under Excel. We can create maps. So if the calculation sheet there is information on coordinates or address, so this addition to SIM or Excel will allow to create a map where we can do some analysis, add some more information from our system. And Krzysztof Wojsław from Bartek, are the results of our calculations automatically transferred from the calculation software to the model? If it was not possible, then how did you do the information exchange? I have already answered. So we did PALs, and they were the easiest. Other elements of the structure was too complicated, and to facilitate the process in calculation model, there were too many simplifications to send this information directly. And as for the information flow, the cable or compression cables, we had more 300, and each of them had a different geometry and a different name. So the information flow was achieved, and we exported this information, names from the software. So we did the calculations in one software, and there were some names assigned, and the same name, they were exported to the model for the constructor on site to find the information about the location and other details. WOA, question to Krzysztof Wojsław. In the entire process, is there space for analysis, optimization of the solutions, and like a volume of reinforcements and changing and what is the workflow between the stages, like generating and verification of the solutions? The question I think will be long, but please try. Let me answer. In this project, there was no time for this advanced optimization, but in another project, together with Sweco in our Swedish office, that was optimization for a common foundation. There was a vertical force and the pressure of ground, and with generative design, so advanced parametric designing, modeling, that was computer, was looking for the results. And there are many types of software like Galapagos or Octopus. So we used Octopus to find the optimum solution. So we had a foundation, and we were able to upload some original dimensions. We were able to upload the price of reinforcement concrete and the influence on the environment, like CO2 emission. So if these parameters are available, the software can analyze 1,000 solutions in terms of dimensions and the volume of reinforcement and the ratio with concrete. So after generating of 1,000 solutions, the software will suggest the best one, the most optimal one, and the software can be required, either it is the environment or the price, and you will be able to see the most the solution which is the best for you, the most interesting for you. Thank you very much. I do not have more questions. We have very little time for the break. And right after the break, we will have the workshop session. We have planned 5 workshops. Thank you for the speakers, and let me invite you to enjoy the break.